OpenAI is out with performance results for its first custom inference chip called Jalapeno. The ChatGPT maker says in tests its chip was faster and more efficient than Nvidia's GB300 system. Richard Ho, OpenAI's Vice President of Hardware, is with us here in San Francisco. I think let's start with the basics of the testing and the performance benchmarks that you've published. What does it tell us about Jalapeno so far?
First of all, thanks, Ed, for having me here. The benchmarks that we did were with an open source kind of benchmark called Inference X. And we did that because it was a fair, kind of neutral benchmarking method. What we're seeing with Jalapeno is that we're able to get both high throughput and low latency with the same device, which is kind of a first in the industry. And why does this matter is because high throughput means that you can serve a lot of customers with a lot of tokens much cheaper than you could if you otherwise. Low latency gives you very fast response times. And so, the agents will come back faster, you can do, more coding quicker, and that really, I think, is a real benefit for our products.
One of the questions that we got immediately was, why didn't you benchmark against Vera Rubin, Nvidia's latest system that's currently in full production? I guess the answer is quite simple, that it's just come out.
It's just come out. We wanted to use numbers that have been published, that have been optimized. Those were available, the GB numbers. The other chip makers also have the numbers in there. It just happens that GB is the best, indeed, product in the current benchmarks that are there.
This is it. This is Jalapeno. You very graciously allowed me to get my hands on it. And again, the whole emphasis is on throughput and ultra-low latency. And actually, in the ultra-low latency piece, you'd associate that with SRAM-based systems. This is both HBM and SRAM. Talk a little bit about its design and architecture, but why that ultra-low latency matters.
Yeah, so it is a HBM-based design. It's HBM4. It's one of the first products that's going to go to volume with HBM4, right behind NVIDIA's products. And it is very low latency. The reason how we got it was really taking a blank slate approach to this design. So my team arrived at OpenAI, and we basically were able to work with the research team to understand where the bottlenecks were in large language models.
Right.
And with a blank slate design, we figured out that you had to reduce your data movement a lot, and we figured out a way to do it. And so this architecture is different from GPUs, it's different from TPUs and other chips in that nature. It really reduces the data movement, it optimizes the algorithm, and then it basically is able to get this very low latency, which matters for the agentic workloads, for example, right?
We're getting to why a frontier lab would look to a custom silicon program, the why.
Yeah.
What is it that you can optimize for with Jalapeno or any custom ASIC or accelerator that you just can't with an NVIDIA-based system, for example?
It's the full stack control that we're really looking for, all the way from the models, through the software, all the way down to the silicon. By having that control, we can make trade-offs. We can make trade-offs and optimize it really well. And that's something that's unique from being inside an AI frontier lab, that this trade-off can actually be made all the way down into the silicon. And with that, right, so I think that the key thing here is that this is quite a novel architecture. I don't think other people have done it this way before, where there's affinity between the memory and the cores in a very integrated way. One of the worries has always been, is this programmable? Right, and new architectures, sometimes it's hard to get the software up, but we're able to show, because of how fast we were able to bring these three very different models that were in the benchmark up and running on this new hardware, which we only got a couple of months ago, is indication of, one, how good the programming model is, and two, how good our models, our AI models have gotten in optimizing the firmware, the kernels, in order to make this performance possible here.
This is an inference chip.
It is.
So very simply, why focus on inference, not on the training side with your custom silicon program?
Well, I think that if you look at it, right, OpenAI has this enormous need of compute. And where that growth of compute is really on the inference side. We need a lot of training, and we have a really strong partner in Nvidia who has, really got a great training chip. So we focused on where we thought we needed to increase the amount of compute that OpenAI has available. With the growth in our users, with our weekly active users growing very, very fast, we saw the need to continue to have a wide range of inference products, and this is going to be part of our fleet, along with our existing partners who are providing us other chips.
How do you decide which workload goes to Jalapeno versus Nvidia or Cerebras, for example. You have options, but how do you make that decision?
It's a great question, right? I think with this optionality that we're now creating for the company, I think that we will be able to provide users with a range of models that have different cost benefits and different latency capabilities. We will map that ourselves. We will map out which product, which SKU, which chip is best for which one of these models. But the whole goal of this is to deliver more intelligence to our users at a lower inference cost, at a lower infrastructure cost. And that's what this is part of that entire strategy that we've been working on for a while now, right?
Lots of people struggle with the benchmarks. To the layperson, it's difficult to decipher. So in very simple terms, on a dollar per token basis, how does Jalapeno stack up against the other options that are out there? How has this changed the economics for you?
It should drop it. It's a really good chip. It should drop it by a lot. The performance per watt that we're seeing, which is a good proxy for how much token will cost, is somewhere in the region between 1.8 to 4x better than other existing chips right now. And so we should see that ultimately when this rolls out into production, customer token prices should come down. That's a big drive that we've had at OpenAI for a little while now. And this really is part of that strategy. And again, it goes back to attacking not only the software, but attacking it all the way down into the hardware and even into the data centers as well.
You are the VP of hardware, not just a single chip. Talk about the challenge of scaling Jalapeno. You do this in partnership with Broadcom, right? There are still bottlenecks in high bandwidth memory. Ramping output takes time on the fab side. What's that like?
Yeah, totally. I mean, yes, Broadcom was our big partner in the chip design. Celestica is our system partner, who basically did the racks, doing the racks with us. This is the big challenge today, right? Memory is highly constrained. Wafers are highly constrained. We rely very heavily on our partners. We also take control of that and have direct relationships with many of the vendors that we operate with. And I think it's one of those things where, I think we have to work together to basically be able to ramp up the volume and get us into high volume production.
Richard, 2 rapid fire questions. First, percentage. How much content does OpenAI own of the server design?
We did the entire design. Broadcom has done the physical design, which is like after you take the logic design, you turn it into the masks that TSMC would manufacture, for example. That was so that's where the breakout, the separation is. On the system side, we did the design and Celestica co-designed it with us.
I ask because these days, Nvidia is pushing 55% of the ownership of the content of the server design. In the future, how much proportionally of your inference workloads do you see being run on custom silicon versus third parties?
I think if we can ramp it and if the cost
is as good as you say.
Good. If it's good as I say, I think we'll see a lot more of it coming up. And I think the other thing I want to highlight is it's a multi-generational roadmap. So we're already deep into development of our second generation of this device, and we're already starting concept work on our third. So we see this as a long-term bet to lower the overall infrastructure cost for OpenAI.